Hiya, it's Mr. Baker here with another physics video, and today we're going to be doing the practical for specific heat capacity. Okay, so we're going to be using Focus e-learning to have a look at the specific heat capacity practical. And remember, for these things, what you've got to be able to do is you've got to be able to describe the method that you would use if you were to do this experiment, maybe analyse some results, maybe evaluate the conclusions and things like that. So here what we can do is we can, if you remember, specific heat capacity is the amount of energy it takes to raise the temperature of 1 kilogram of an object by 1 degree. So we're going to try and find out the specific heat capacity of a specific metal. So we've got some different metals that we could maybe use. We've got aluminium, we've got copper, and we've got iron, and we can switch between those. So we're going to stick with aluminium. We've got 1 kilogram of the metal block. And so what we've got to do is we've got to work out how much energy we're going to input into our metal block over a certain amount of time, see what the change in temperature is, and then we can use that to find out the specific heat capacity. Okay, so the kind of equipment that you have, there's a couple of different ways of doing it, but this way here, you've got a metal block which has got a couple of holes in it, one for a thermometer and one for a heater. So you would place your heater and your thermometer into your metal block, and then you would put some insulation around it, some lagging it might be called, around there. And then this heater will be connected to a power pack, and then the power pack you'll need to know the potential difference of the power pack and the electric current going through your heater as well. Now what we can do, this method here, we can use this equipment to find the energy by using an equation, the current times the potential difference times the time. That will tell us the amount of energy that we've used. So if we know the energy, we know that the mass is 1 kilogram. The equation is E, so energy equals mass times specific heat capacity times the change in temperature. So to find out the specific heat capacity, then we need to know the energy divided by the mass times the change in temperature. Since the mass is 1 kilogram, our specific heat capacity is going to be the energy divided by the change in temperature. So we'll need to calculate the total energy for the time that we have got, and then divide that by the change in temperature, and that will tell us the specific heat capacity for our experiment. So what we would do is we would turn on the equipment, start the time, and then we would plot some points on a graph similar to this, where we'd have time on the x-axis and temperature on the y-axis. So if we have a go at this one then, so you can see we're starting at 20 degrees, and so we plot this point, and then let's go every minute, let's plot another point. Okay, so we've got here a graph that you can see sort of curves up. So what we'd need to do is we'd need to look at the energy under that graph, the change in temperature over that time. So the change in temperature would be the total change in temperature, and then our energy would be our current times our potential difference times the time. So current 4.17 times the potential difference times the time, and that would be 10 minutes, so we'd have to convert that into seconds, so that would be 10 times 60, so 600 seconds. So 4.17 times 12 times 600. Our change in temperature divided by that, and that would tell us the specific heat capacity for our metal block. Now, one of the reasons we might not get exactly the same specific heat capacity as it should be is because not all of the energy may have gone into the metal block. So if our metal block isn't completely insulated, then that would mean that some of the energy wouldn't go into heating the metal block, it would actually go into heating the surroundings, and so then our specific heat capacity that we calculated wouldn't be very accurate. So that's a really quick demonstration of the specific heat capacity practical, and I've been Mr. Baker, and I will see you next time in another physics video. Thank you.